Alright, moving on to problem 3. Bingham High decided to start a rumor. Savannah started a rumor. And she tells 3 people. And they need to then tell 3 more people the next day. And then each of those people then tell 3 more people. And it spreads around the school. Okay? So on day 0, the day she starts, 3 people have heard the rumor. And then as you move down, you're multiplying by 3, because each time, each of the people that heard it the previous day then tell 3 other people. So you're like at 9, 27, 81. Let me figure out the rest ones real quick. Alright, so I filled it in. Once again, you use timesing by 3 each time. And on my days here, I'm going to count. I'm going to skip like 3 every time just so I can fit it in here for, there we go. And then on the vertical axis, I'm probably going to count by a pretty high number, but hold on a second. So I decided those solid lines going up, I'm going to count by 700, and I did that because on day 6, I'm getting a little bit above that, and so my point here at day 6 is going to be just a wee bit above the line, and everything's going to grow up to that point. So starting point is basically 0, and same thing on day 1. In comparison to 700, you're way down at the bottom. And you're starting to get a little bit of growth here. It's starting to actually make a dent when you get to day 4, which is which is 243, and then day 5 you're at 729, and it's going to grow like that. So your graph is going to look like such. Right? That's exponential growth right there. In the context of a function being discrete or continuous, this one is discrete because like half a person can't hear the rumor or anything like that. This equation is 3 to the x power because that's what you're multiplying by each time. That 3 there, that's a factor. You're multiplying each time, each day. And there you go. Last question. Alright, so I had to read through it. So on the start day, on day 1, so no days have passed at all. You start with 4, and then each day it's going to double. So you're like at 8, 16, 32, 64, and it's going to just keep growing and growing and growing. Yeah, it grows a lot like a computer storage space, which is this binary system here. And it just keeps growing up and up and up. And yeah, it just keeps growing. We need to get up to 500,000. That's going to take quite a few days. Let me count it out and draw them out real quick. Alright, so I got it all calculated out and I got my axes going. So it turned out that it took 17 days. And so the way I got that is each day you gotta times the amount by 2 all the way. Keep going until you get here, which is 524,288, which is 500,000, which is half covered pond. And so now I'm gonna graph this real quick. When you start at 0, 4 is basically nothing in comparison with these really large numbers. And I have those large numbers because I need to get up to 500,000. I decided to go with 600,000 because that divided by 3 evenly, which made these ones a lot easier to put down. Anyway, so I'm going to put just like 5, 10, 15 down, mostly because there's a lot of days and I won't be able to put all those dots. And when you're at day 5, it's 128, but practically nothing in comparison to 200,000. Even on day 10, when you're at 4,000, that's a little bit up, but not hardly at all in comparison to 200,000. But once you reach Once you reach day 15, you're at 130,000, which is a lot higher. And on day 17, you're all the way up here, practically at 600,000. So this one increases rather drastically as you get there towards the end. Man, I can't get this curve right. Anyway, it goes like so. It increases really, really quickly after you get past pretty much day 10. And the two questions here, is the function discrete or continuous? This one, again, would be discrete, because the number of leaves, you won't count like half leaves when you're counting that. And the function here, the 4 stands for your start value, and the 2 to the x, that's the factor that we're timesing by each time.